Now, I've been using Grammarly for years.
Hey Gary, how you doing? Ah, good, awesome. Nice. That's great. Twitch. Definitely. Yeah, you have. Nice. You have the setup ready. You can see. That's great. No, I got this plugin for OBS. You tweak the settings a bit, and it's pretty good. Like never fails. Uh, I realized like if I come with my head across the screen top, check this out. Boom, it breaks. Then you can see my surroundings. That's it. Yeah. Mm-hmm. Yeah. I wanted to ask, like we did last week, if you could screen share with me so I can see it in real time as well. Do the Twitch delay. Yeah, everything in its on its time. Ah, did it? Yeah. Got moved around, right? I'm guessing. Mm. Yeah, there was like a third participant, just like how we have it now. Yes. Yeah. Yeah, I was trying to finish. Yeah, trying to finish chapter one. It's that's good because I need a review for sure. Yeah, there's not a lot of a ton of code. The methods for like multiplication and exponents, right? They're not that complicated. I was trying to really understand the finite field multiplication, subtraction, but yeah, just the operations themselves. Yeah. Which one did you were up to multiplication? Is that it? Mm.
Um,
Oh yeah, I'm connected on Twitch and
check, check. Okay. Yeah, no, I see audio levels now.
yeah,
Because you were a little quiet last week, I think, but it was still audible. Um,
I was. Oh, good to know.
but anyway, yeah,
Mm.
let's program some Bitcoin, huh?
Yeah, let's do this.
And yeah, I hadn't gotten to the multiplication, but I did read through some of it, and it basically just
Mm.
explains it's like multiplication is just you do a bunch of addition over and over and over again, right? Like that's like the core of multiplication. So it kind of makes sense that you would just do that anyway for this modulo multiplication. That's gonna be a tough one to say, I think. Um,
Yeah, multiplication is pretty straightforward. It's basically yeah, you multiply it and then you modulate it by the prime,
yep.
the finite field.
What is the what did you use any test numbers?
Not like you were showing to me last week. I
Okay.
did the on the like the Jupyter notebook that they offer.
Yeah.
That would be on the Python side, the Python side. I did run the tests and
It
I was
passed.
able to get through.
What are the tests they give you? I'm curious because I want to match my test with your tests.
It's uh it's very interesting to get a chance to try out the Jupyter notebook. It's they have the tests like pre-made and they
Oh,
ask you like
okay.
build the power class or the exponent class.
Yeah.
And then you just click to run and the test passes, you're good.
Interesting.
So
Okay.
they have the test pre-programmed. So I guess the multiplication multiplies two different finite fields, and if it's equal, then it passes. You know.
Yeah, yeah. I'll make a note here to before the next stream to get that Python notebook. Or are you able to share that? Is that like a local thing only on your machine, or does that live in the cloud somewhere?
Mm. Or maybe the yeah, it's in the repo, but that's I don't know if it's yeah.
No,
I can find it on the repo, but
no worries, no worries. I'll get it set up for next time. Um, but I
mm,
am curious if you could bring it up. I'm curious which number what like examples you used, and then
yeah,
I'll plug in the same numbers for the test here, so that way
mm,
we're not going too far off book.
or multiplication, right?
Yeah, for multiplication. Yep, yep, yep.
Yeah, let me find it. It is running.
And I thought it was pretty interesting too how it's like exponential is just keep multiplying, which that's what it is, right? Like that's the simplest thing of it. And then I just imagine, you kind of break it down into from exponential into addition, and you just have this huge like addition problem of just like the same number over and over again, which is pretty
Yeah.
wild.
Mm-hmm. I'm cleaning up my windows. This is good.
I think I just used the one example here they had for coding multiplication.
Mm-hmm. I'm gonna need a third screen.
Oh yeah,
Screen's not enough.
we'll work on that. I've got an extra one I can ship you.
Okay, sounds good. As long as it doesn't take longer than the mempool right now.
Oh yeah, I saw your tweet about that. I'm assuming
Yeah,
it's pretty full.
yeah, I don't know. Like I don't have a lot of history, in the mempool getting clogged, but right now there are 38,000 transactions in the mempool. It's like 800 blocks or so.
Oh wow,
Yeah, like a full day of blocks, non-stop, full.
wow. Okay. Well, I'm glad I'm not moving any Bitcoin today.
Yeah.
So I mean, I feel like based on these other sort of like operations, it's gonna be pretty simple. And instead of minus or subtracting, I just multiply. Is that? I mean, is that what you?
For multiplication, yeah,
Yeah.
it is the same. Yeah, simple.
Okay, that's what I thought.
So when you're doing it on Rust.
I am. Yeah. I still wanted to try it on Rust here. So we'll write. I feel like going through the mental model of doing it versus writing the code is just so different. I mean, the mental model is way more like, I don't know. You don't realize how much your computer abstracts away from you until you actually like go to do something on paper again, right? Like writing out the whole.
You mean that comparing Rust with Python?
No, I just mean like doing exponents and like breaking down like what an exponent is. I always forget how complicated that is, and then how easy they make it in in programming. Like your computer just does so much for you.
Mm-hmm.
See, it's complaining about something here. It should work now. Let's test it. Hey, cool. Multiplication works. So is the next one? Go ahead.
You're using the test that you programmed there, right?
Yeah. And I just got this from the book. I don't know if that's.
Like the fields. Okay, let me see. The multiplication. Add the 6.
Just have it's probably nice and organized in that Jupyter notebook too. I should really look into that.
Yeah, so for the test, test multiplication, it was 24 on a field of 31
Okay.
times 19 on a field of 31. And the result should be 22.
$24 times 19, 22. Such a strange thing to say. Oh, there we go. Forgot. Cool. That works.
That worked.
Yes, sir. That worked. Okay, so you did the exponent then.
Yeah, real quick. Sorry, still in the
Sure.
multiplication realm. I was learning how to do these calculations, these modular calculations, by hand. So you know how to calculate this multiplication by hand?
I think so. I mean, all right. So let me try this.
What the operations are.
I'm fairly certain I do. I'm gonna bring up a calculator.
Oh, for sure. Mostly the modulo calculation. That's the one I was, trying to figure out.
Yeah. So I think so if I do 3 times 12, which that's what 36, and then mod. Oh, that's not it. 36 divided by 13 gives me that number, which is really 2. So what is 13 times 2? It's 26 minus. Wait, hold on. Yeah. Whoops. I got lost in the sauce there. 12 times 3 is 36. Divided by 13 is 2. And then if we do 2 times 13, we have 26. And then if we minus 36 from that, it's 10. Which it would just be the inverse because reasons. Oops. Uh-oh.
For which multiplication are you running?
The 3 times 12 of a field of 13.
Okay, nice. 3 times 12 and
And it'd be a similar thing for the larger numbers. So it's the prime is 31, so 24 times 19 is 456. So let me jot that down so I don't remember it. 456. And then we divide that by 31. We get some big number, so 14. So 14 times 31 is 434. We do minus 456 and gets us 22.
Oh, interesting.
At least that's how I do it. I don't know. That's my.
The way I was doing it, and it's kind of dirty.
There's nothing dirty about it if you get the right answer, right?
You kind of get it. So do 24 times 19.
You said 24 times 19.
Yeah, it's doing the same multiplication.
Okay.
Then divide it by 31.
Okay.
Then you grab the decimals, multiply that by 31.
Really?
There you go.
Oh, that makes sense because the decimal is kind of like I don't want to say it's a. It kind of represents the remainder sort of thing, right? Like.
The remainder of that, that
Yeah.
cycle, right? That prime.
The remainder divided by 31 is that decimal place. Okay, interesting.
Yeah, I liked yours though. Yours is like you just get straight to the result. You don't have to parse through.
Hey, like I said, the right answer. There's no wrong way to code it, right? Like or to think about it, as long as you have the right answer. The objectively right answer, and that's always the hardest part, right?
Yeah.
Well, let's do talk me through some tests that you had for exponential.
So exponential, what we had was also in a field of 31.
A field of 30. Okay.
Yeah, on a field of 31. So the test is a little different, Would it be easy for you to share the session via Code? Then I can.
Yeah.
Live share thing. It's so cool.
Boom.
Got it.
Yeah, I do see they have one here in the book. So one of the cool things, I mean, I guess it's cool, um, but with Rust is like you can just kind of reuse the same variable names. It kind of just like overwrites it, sort of thing, and it has to do with the memory allocation,
Mm,
from my understanding.
mm. And when you create a new variable, it already ejects the previous one.
Yeah. So like we create a here, and this is fine in this scope. So like up until a is recreated here, um, which is not something you can always do in a lot of other strongly typed languages. We'll say. Were you able to join the sharing session? Yes.
Yeah,
All
I'm
right.
here.
Cool. Cool.
Let me grab the test. So the test that Jimmy put in for the exponential is your first different language.
Oh
I'm
yeah.
trying to
Well,
figure out why is he maybe he's doing the same thing. It's two tests, right?
yeah. This definitely looks like two tests.
So this is the first one and the second one.
Mm-hmm.
Yeah, that's it. Yeah.
Oh, because he's doing an exponential multiplied then by another field element to get a result. So we'll have to add that test in here as well.
Comment this out.
So 17. Um. Whoa. I guess assert equals is okay. It's all raised to the power of 3. 31. So that's obviously not going to work. We can run it and it will be like, what are you trying to do? You can't, yeah. Cannot be. Oh, yes, I forgot. It's not, so the stars have special meaning in Rust, because it has to deal with like memory pointers and referencing memories and stuff. So we'll have to go look. I don't know exactly. Yeah, okay. So use the caret in Rust. That
What?
caret, this little, yeah, caret. I think that's what it's called.
Okay.
Caret. Do. I thought so.
Alright.
Maybe not. Wow, that's bling
Might
bling.
be.
Caret. Oh, ET.
Yeah.
That's my mistake.
Mm.
So yeah, it's a caret.
In Portuguese, we call it like there's a like a formal name, but we also call it like a hat,
A hat? Okay.
little hat.
Little hat.
I like that.
But what is the actual
Like circumflex accent.
Oh, that's wrong. I'm sorry. This is the question. Okay. First of all, have you heard of Stack Overflow?
Oh yeah, sure.
I
It is the
I
king.
made the mistake of looking at the question for the answer. You have to scroll down to get the answer. So yeah, we have to do this POW method, which makes sense. And we'll probably have to implement that somewhere. Well, not probably, but we will. We'll definitely have to implement that somewhere. So I'm pretty sure there's a way to number traits POW. I wonder if there's a Rust not override. We have to implement POW. And I wonder if it's the same as these multiplication one. Mm-hmm. This has this has to do with like traits and stuff. This is where the it's probably a little bit easier to do in Python. Returning none if an overflow occurred. That's interesting.
I guess yeah. With exponentials, we always worried to not end up with like a gigantic number.
Yeah. Makes
In
sense.
Python, there is the pow function. It takes three arguments: the number you want to multiply or multiply to the power, then the power, but then you can also add a modulo at the end.
Oh, really? That's
Hmm.
super simple.
Yeah, so it kind of contains the number because it modulos the exponential after each multiplication, so it contains the number. It becomes pretty small. All of that.
Ah, okay. So I think okay, so I think we have this. Um, were there any considerations for doing that?
Go here because the main difference with the it's exponent, right? The differentiation.
Yeah,
Thanks.
exponent. Yep.
The difference was that for multiplication, uh, addition, and subtraction, we're doing finite numbers, right? Two finite fields. But with
Right.
exponentials, we're doing it with a different number, like not another finite field, which I think it's what you're doing.
Right. Oh, okay. So you're taking okay. So what you're saying is you're taking in this other number is not necessarily a finite field. It it's probably going to
Exactly.
be another. We'll call it another U64 right now. Um, I get it. Yeah, because you can't necessarily. Does it
Yeah,
explain
you
why that
can.
is?
Yeah, I'm looking it up here. Mm,
The exponent is an integer instead of another finite field.
there you go.
Hmm. Okay. Well, this
It
still should
doesn't
be pretty
explain
straight.
why, right?
No, it doesn't necessarily explain why, but still should be pretty straightforward, I think. I mean, just looking at the code there, we're just doing. So we want, where is it at? NumPow. I wonder if we have to install NumPow. And the number. See, I don't think. So this, yeah, this is, I think, excuse me. Um, this is a crate. So that's like a library package. So if we go, we have to, there it is. So we copy it out and we have to put it into our cargo here and then do a cargo install. Oops, not go install. And this will install that num package for us so we can use it in our code. Or it should, unless I'm way off the mark on Rust here. But I'm learning Rust, so could be.
I was trying to remember what's the name of the nice looking uh, terminal skin that you have?
Oh,
Theme, right?
oh my posh.
Oh my gosh, that's it.
And this
I don't have
is
it anymore. Let's see.
waiting for file lock on package cache. All right, well, let me restart this real quick. Oh, I'll probably have to re-invite you to the session then, huh?
Because you're reloading the.
Yeah, I reloaded the entire window.
Oh, let me see. Oh yeah, I'm disconnected. Let me see if I can use the same link.
Go ahead. I feel like it probably killed it. So yeah, it killed it. So I'll send you another link. Sorry about that.
Mm. No worries.
Waiting for file. Oh man, what's going on there? Ah, okay. It's conflicting with Rust Analyzer, is my understanding. There's something out there that's conflicting.
Mm.
Oh boy, we slowed way
Do you
down.
have a VS Live Share account, or you just use it anonymously?
I think I have an account. I do accounts for stuff. I've got. There's a. If you're ever looking for something that's, I don't want to call it funny. It's not funny. Um, but basically, there's this government organization called OPM, and during my time working in the Navy, OPM was hacked, and so all of my data at OPM, to include my social and all that jazz, is out there.
Mm.
And so I'm really bad at OPSEC. I guess that's like a long way of saying that I'm really bad at OPSEC.
Well, you were rugged basically, right?
Basically, yeah, I was rugged. Yes, I was. Yep, that's wow.
Because you had to share your info, right?
I did. Oh yeah, yeah. I mean, they, um, when you're in the military, they own basically everything about you.
Of
So
course.
this is.
And that's the danger of KYC in general, right? The bad
I think
guys are
so.
always
Yeah.
they're gonna be able to do whatever they want to do regardless. But
Yep.
the good guys will share their info and then get stolen.
Yep.
So,
Man, what is going on with this thing? No package found with binaries or example. Oh. Solid Rust binary. Okay. Yeah, we already did that. So does it just pick it up then?
do it again.
I'm wondering if it just picked up.
Oh, like the module that you just installed.
Yeah, did it just pick it up? And I think we need to move this. So we're not implementing POW, or we're not implementing POW or power or exponent for. Because these are like overrides, so it allows you to do like the star and the plus sign and stuff like that.
Mm-hmm.
But because we're not doing that, we need to go up to just the standard implementation. Whoa. All right, there we go. Base and then exponent is other. Okay, so it's a type match match. It doesn't like the size U64, so we'll just do U size. That's fine. And then we're actually back to programming Bitcoin here. Oh, and then we just mod by the prime. And we return ourselves. Nope, it's not new. Just return a field element. The new number. And self.prime. So now, instead of... Oh, that works. Let's see if it works. Shall we? Okay, here's where it's pulling in all of the num crate. All right, something failed. Uh-oh. Assertion failed. It's panicking. Why is it panicking?
Some line numbers or something. Do you know what it is?
It's so so this is where not right off the back. But I mean, we can see that it failed on line 127 in field element RS. So that's our test. So it's this initial assertion. I wonder if that was just maybe the wrong way of implementing it. And there might be actually now that you mentioned the Python one has like a way of doing modulo. You said it does modulo power?
Yeah. After each iteration in modules.
Is that what you use for your implementation?
If you go to the end of chapter 1, Jimmy will mention that. So like one section before the conclusion, keep going. There's like redefining exponentiation. He's gonna mention that.
Okay.
So he makes it work for negatives and also substitutes the power function.
Okay. Well, I don't want to get too far ahead of ourselves then. Modular exponentiation? Exponentiation. Words. And this process for students. For remainder. Give me the Rust code part. The key to all that stuff is being able to do the modular exponent really fast. I probably should actually read this. But we're not here to read, we're here to code. Hey, here's this. Okay. Mod power. So this mute keyword is referring to mutation, meaning that this variable can change, like it can be updated later.
Changing.
Just in general.
Not a constant. Or change even the type.
Right.
The type can be changed. Of course, the content can change always, but the type as well.
No. The content generally. I mean, maybe the type can. Interesting question. But let's see if we can do this. Modulus. Base exponential. Modulus. Oh, that would just be we already have that. That's just the prime number. So we're passing self and then the exponent. we know that self dot. We know that the prime will not be 1, so that's fine. We'll make sure this is a 64, U64. And the base is not base, it's self dot number. Self dot prime. And I wonder if this is already implementing it the way that Jimmy changes it in the book. Because this looks like it's assigning itself. So, hold on, where's that test? So 3 and 13. So it's 3 mod 13 is going to be 1, right? Because 3 times 4.
It's 3.
3 times 4 is 12, with a remainder of 1.
It's 3. No, I'm sorry. It's the other way around.
What's that?
Wait. No, yo, that it is the case. Yeah, so 3 mod 13 is 3. If the number is smaller than the mod, it's always the number. And we can confirm that. Make sure I'm not going crazy.
But 3 goes into 13 4 times, and that's 12, and then you have a remainder of 1.
That would be 13 modulo 3, the other way around. Or maybe that's what you have in mind?
No, 3 mod. I'm curious.
Maybe you just run a REPL or something.
Yeah.
Pretty sure, yeah. 3 mod 13 is 3. 13 mod 3 is 1. Driving.
So 3 mod 13 should equal 1. That's what I'm saying.
Mm-hmm. Oh, I think it's 3. I think the other way around would be 1.
What? Oh, okay. Hold on. We got bad code. It won't let us compile without the bad code. With the bad code. Oh, come on now. Gotta comment out all the code. Why? Why is that? Why is it 3? Talk me through that. What did I miss here?
I was kind of I can't really explain it, but it was just such an easy rule to remember, like to learn, that if the first number is smaller than the second, it's always the first.
Okay.
Like if you do insert and you do like a bunch of numbers, mod, and then do a bigger one,
It's going to be this, equal to
it's
this.
gonna be this exactly.
Oh, I get what you're saying. Yeah. Okay. Yep. Do we run? Oh, it didn't like. Okay. Oh, there's data type limits. It's yelling at us for number sizes. It's out of range.
And then yeah,
All right, those are small enough.
you're right.
Nice. Passed. Okay. Yeah, okay. I get what you're saying now, because the mod is what you're dividing by. Not. Yeah. What you were saying, 13 mod 3 is 1.
Mm-hmm.
Yep. Okay. Beautiful. This is why we do it together.
Yeah. love this live share thing, man. So I can see like when you're running the code, I can see the terminal here.
Yeah, nice.
Yeah.
So okay, so all right, so if that's itself, then um,
Mm-hmm.
is the modulus isn't is the modulus prime then, right? Or no?
Mm-hmm. Yeah, for finite fields, it always has to be a prime, right?
Right. But what I'm saying is the base here, the base number is always if the base number is the number in the field, it's always going to be, because the number in the field is always smaller than uh than
Oh,
the
right.
you know what I mean? So I don't
Yeah, so
think
if
this
you
is going to
mod,
work.
oh, right, good point. Because if you mod, it's always going to be the same number, yeah.
Yeah. So I don't think this is going to work. But I think we got something here that we can go with, and we'll just
Mm-hmm.
ignore this code for right now. Um, we should be able to do. And it would be just taking the base, which is going to be self.num,
Mm-hmm.
and then we're going to have to rechange this back to usize, which is fine.
Usize, what's the size for usize?
So usize is, it depends on the compile time for like, um, yeah, the size of this primitive is how many bytes it takes to reference any location in memory. On a 32-bit target, it's 4 bytes. On a 64-bit target, it's 8 bytes. So what Rust will do is, depending on the language that you're compiling for, or not language, for the like the architecture, whether it's 32-bit or 64-bit, it will like auto do the thing for you. So we should probably use usize, honestly, for most of these things.
Yeah. Usize fits all, basically.
Yes. Yeah. Basically, I will. I won't forget that one now.
Number all set of numbers.
And that should give us this. And I think we should just, now we just mod this, right? Mod by self.prime. And then we just return a new field. Pow. All right, let's see if this, let me get this thing working. Run the test. Hey.
Yes.
Okay.
These are the tests from the book, right? That I pasted in you, translated them.
Yeah.
Yeah.
Yeah, so 3 and here, we can get rid of this. 3 and 13. I think 3 and 13 was in the
Oh no, different one, yeah.
that was in, that was it.
One also involved
That was
multiplying.
that was this here. Yeah, we didn't do this one, so I guess we should. So let A equals field element. You feel free to start typing B while I'm typing A.
Okay.
Oh, that's weird. Oh.
That's it. Yeah.
You forgot to put new in here.
Oh, cool. Okay.
And then, yeah, cert. And this one is interesting. So it'll be a.pow. Because it's not, we don't use like a caret or a double asterisk. It's a.pow. Whoa, why are we capped?
Like a method.
Yeah, it's a method.
That you just created, right? The method that you
exactly.
we were just working on.
Yep. We just implemented the pow method. But we're taking that and multiplying it by b. And that should equal.
You have to pass the exponent in the parentheses, right?
Correct, yeah. And if you, as you're typing, I don't know if it, does it show up on your screen, kind of like the hints? So like on mine.
No, I think I have to.
When I do that, it kind of
for Rust.
Okay.
But maybe even if I had it, it would still only show. Oh, actually, I get them when I type here. It does show.
Oh, perfect. Okay, cool.
Yeah, I see here, exponent u size.
Yep.
5 and then you just instead of assert equal like we have here, it's just an double equal sign.
And I mean, Rust has like an assert equal macro, it's called, which is a very similar thing. And again, this is so for this you have to do the colon new.
So we find a new object.
Yep.
New instance. And I'm still getting the highlight here. I'm probably missing it.
Missing is
no, it's good.
What are we missing here? Oh, I see.
Am I calling?
Yeah.
I like the I see. Mismatch the close and the limber. Oh, not anymore.
What's that? So this is
See what I did? I missed the.
Oh, I missed the semicolon up here.
Right.
You did, yeah. So actually, I was gonna leave you. Hold on, delete that let, because I was gonna let you do that. I was gonna let you do that, and we'll run the test, and you can see. So, let be right on line 133, and then line 137. You cannot assign twice to an immutable variable. So a way to make this work, though, is if we go like this and make these mutable, and now we no longer get that issue.
Nice. Is this kind of Java-like?
I don't know if it's Java-like necessarily. I mean, Java's pretty flexible. Like Java will let you just change stuff depending on what you're doing. Yeah, so and it even gives you the beautiful thing about Rust is it tells you kind of like, hey, maybe you should, make it a mutable variable. Or in your case, what you're doing is you're just kind of overwriting it. You're just like paving over it.
With the lets are always like paving over the previous one.
Yeah. And it has to do with the way Rust does memory in this thing called scoping of the memory. Which we have.
To explain, but how come? Sorry, I was gonna change the subject, so go ahead.
No. How come what?
How come like the POW doesn't accept, like doesn't override the default double star.
So because
Like
default
this.
double star is something unique in Rust, and it's a dereferencing. Um, so in Rust, this star, it drops a or dereferences something. I don't know how. This is where my knowledge kind of is limited. Um,
Mm-hmm.
Let me see here. Let's go back to Stack
But
Exchange.
so a star plus something means like something
D-
totally different besides an operation.
yeah, it means dereferencing it. Um, it kind of like it allows you to take ownership of it. Maybe that's not the right word either. Um, yeah, it's
It's just a
you can.
choice. Like
What's that?
they don't. There is no like built-in way to do the power of.
No,
It's
no, yeah, I don't.
directly made.
No, because it has these special symbols. From my from my understanding.
Mm-hmm.
There's another stack over with the ampersand and the star. Oh yeah, here's a huge long, long explanation. I mean, not super long. I'm sure there's a lot more to it, but it has to do with like the memory, um, the way Rust handles like ownership and memory of variables and stuff. Um,
Mm-hmm.
and I'm not smart enough to explain that part.
Oh, no, I got the vibe.
Yeah, it's just because the asterisk a reserved symbol, I guess, would be one way to
Mm-hmm.
put it. So
And he didn't substitute it by anything else, right? There's no built-in way of doing exponents. You have always to you always have to use the method.
right,
This
right,
one, right, is just a few characters more.
yeah,
Right. Yeah, it makes a big difference. 2 characters versus 5.
yeah. I'm not a big. There's something called code golf where it's like, can you write it in the least amount of like characters and lines? I'm
Mm-hmm.
personally not a huge fan of that because I think it makes it less explicit and less readable. Like you kind of have to know how to read it in order to read it. But like if we change this, to the power of, right?
Mm-hmm.
And now it's a lot longer, but
And
you
it's
read
big.
you read the code, and even if we took somebody, that just knows math or whatever, or like somebody that isn't necessarily like coding, now when they go and read this, they can see, they might be able to understand it a little bit better without having to understand. Oh, what is this POW method? Like what? I don't POW what? Like proof of work?
Yeah.
A field element has proof of work on it? No, it's just it's to the power of, and then you give it what you want to raise it to the power of.
Yeah.
That's my personal opinion. There's all kinds of flame wars around like naming variables and shorthand and like all this other stuff.
Real quick, how did you replace all the powers by the power of? Did you
Oh
find replace all?
no, so there's a shortcut in VS Code F2. If you're on,
Mm-hmm.
I don't know what it is on a Mac, but it's F2, and it brings up this
Mm-hmm.
kind of rename, and we can
Mm-hmm.
well, we can rename it whatever we want if we give it a valid name.
You select.
You just click in it, like you put your cursor on it
Okay.
and hit F2.
Ah, I see. Did it at the same time.
Another thing is you
And
see how it kind of highlights all the other instances?
mm-hmm.
Control Shift L will like put your cursor at all those instances.
Nice. Let me see. deprogram. I programmed a shortcut for Control Shift L or Command Shift L in my case.
Ah,
It's really
okay.
lazy. It like cleans up the line and adds an extra line. But I haven't used it, so I can get rid of it.
Okay.
I love my shortcuts, man. I'm like
Do
I
it.
spend so
Yeah.
much time creating shortcuts.
I'm a big fan. I'm a big fan of shortcuts, at least for things that I have to do more than once.
Exactly. Yeah, me too. I think when I do something twice, I'm already searching for the shortcut.
Yeah.
The second time I'm doing it, it's the shortcut already.
All right. Why don't we force the exponent to be a field element object? Okay.
Just testing this.
So what we're doing? Yeah, I'm
No,
just
yeah,
kind of
so
reading.
yeah, exactly what he's talking about. It's large for slow for large numbers, but
Yeah.
then with the modulo, he's gonna fix it, make it more efficient.
Okay. Oh, exercise 7 is you have to figure out what set it's in, huh? That's interesting. I would almost. How did you go about doing exercise 7?
Let's see if I can find the code for this.
I would my initial inclination is to go look up prime numbers and find what prime number comes after 31 and start there.
Actually, in the Jupyter, I think he gives us some clues that it's about iterating. It's like starting a for loop with those p's. Let me find it.
Oh. Um so okay, that's interesting. So I think that if let's think. It's about iterating.
Yeah.
So do you iterate like over those numbers, or do you iterate over the prime numbers to figure out which?
The the explanation is not really great, but I think he wants you to build all four different sets based on those primes that he gives us. Yeah, if you go there, you can look at it together.
Jimmy Song, cool dude.
Have you met him in person?
I have not. No, I've just heard him.
Me
I've just
neither,
heard him
yeah.
talk a few times.
Yeah,
My guess
yeah.
is it's on GitHub somewhere.
Yeah, it's like slash Jimmy Song slash programming.
Programming blockchain. What? There's Jimmy Song. Let's go ahead and click a follow there.
Yeah, so if you code chapter 1 all the way on the top. What's the number of the exercise? It was 7, right?
Yeah. I don't want to just look at the answers though.
Yeah, but if you click on the chapter, yeah, then you can find it.
Oh, yo, it's an. Is this an actual notebook that can run? Huh.
Yeah, they made it. They made such a good job at it.
No, it doesn't. Yeah, it just gives us the array of prime numbers. So how?
Yeah, maybe I was looking at different sites.
All right, so let's think about this for a second. How can we determine what field these numbers are in? Well, how do you describe an element of a finite field? It has to be closed. So meaning that, hold on, let's go back to the definition of a finite field. And I think if we do that, we can like test to see if it meets, if these, whatever prime number we give it, it meets the requirements that we've outlined. Does that make sense?
Yeah, I think though any prime number will work, right? I think that's kind of like the.
Well, a prime number has to be higher than the element, so.
True, true.
So it does have to be, And then let's see, where is it? If A and B are in the set, A plus B and A times B are in the set. So 7 plus 11 with a mod, right? With the mod of whatever the prime number is going to be in this set. Also, 11 plus 17 mod whatever the number is also in the set. You know what I'm saying?
Kind of.
0 exists and has a property, so 0 is in the set. Those are pretty. Okay, 0, 1. If A is in the set, negative A is in the set. Additive inverse. So I guess we need like maybe a list of prime numbers. Prime number generation and rest. Maybe not that. Maybe just a list of prime numbers. What? Wow. Okay. Here's a big list.
All the way.
Yeah. So maybe we'll take the first 10.
I had done it, but I was doing like in a Scratchpad document and erased.
Oh, no worries.
Yeah.
I mean, if you think of it though, chime in. Let me know, because I'm not sure if this is the right approach. I'm just kind of I'm gaming it a little bit by thinking that they're not going to make it some super high prime number, if that makes sense. 1, 2, 3, 4, 5, 6, 7, 8, 9. We need one more. 83. Do you know what the answer is? Do you remember what the answer is?
So, what is this set? I think the question is not well asked. that's where I was trying to find where they talk about iteration of for loop. I think what they want us to create is what they want us is to create the four finite fields for these primes, or at least run this operation, like how you have the brackets or the curly braces, 1 to the power of p minus 1, 2 to the power of p minus 1. He's gonna use this
Oh,
concept
where's the
after.
field of 7? Is that what you mean? Like defining
Yeah, so
what is
build the finite field of
uh
7, build these four sets, one with 7, one with 11, but I don't think they have a relation between themselves.
I gotcha. Yeah, you're right. I'm overthinking this.
Yeah, but the way they asked is not ideal, I think.
Yeah, yeah. Well, hey Jimmy, if you're listening, go change your book.
Feedback.
Feedback.
And I think the only reason I got this is because I saw there was somewhere that they said think iteration or something like
Yeah,
that.
yeah.
It's little.
Well, let's move on to some division, eh?
Mm-hmm.
Okay, so intuition doesn't help us. That's great. In normal math, division is the inverse of multiplication. Yes, correct.
Okay, so what if we go back to exercise 5? I found what I was looking for. That's why I was a bit of
Sure, sure.
oh, come on. Do you notice anything? Yeah, so keeps what comes after y fields are prime? Then there's nothing else.
Nope, that's
Let
it.
me scroll down a little bit. Yeah, so now if you go into the source code for this page on GitHub, you're gonna see that there is like talking about the looping through all possible.
Up
There
to,
you go.
oh, okay. Hint, sort.
Exactly. Yeah. So what they're gonna show us here is that they are all they all become the same. Like the exercises k is equals 1, 3, 7, 13, 18. What is this set in F19 or finite field 19? They're all gonna be the same because the finite field always generates the same number.
Every
That's
time.
why they say sort. Yeah, regardless of the k that you pick for that.
Ah, okay.
Um, maybe if we build this calculation, because I think this one is pretty cool.
Okay, yeah, let's do it.
Exercise 5. And I can do it here. I can do it in the same document in Python, and then we just move it somewhere else to run.
Well, I mean, we could write it here. I'll help make it Rust, I guess. Rusty.
Mm.
Um,
Rusty.
yeah. So, I mean, the first thing would just be we can, just our list of K. Which how many things are 2, 4, 5?
Mm-hmm.
So 1, 3, 7, 13, 18. Why doesn't it like that? Oh. There we go. So now we have K, and we can do for I in K, which I is just a common abbreviation for iteration. And we have prime of 19. And Okay. 4K. What is this set?
It's multiplying
K time.
I. Yeah,
Go ahead. I.
each item. No, the I is the
Iterator.
iterator. So I would be 1, then 3, then 7, then 13, and 18, right?
Right.
That's what we're iterating. Yeah, go ahead.
Like this. We need to.
They used kind of like a sub, like a lambda function or something like that. Maybe let me just. This is what they do in Python. That'd be unique. We print a set, like an array
Yeah.
that also includes a for loop inside.
Huh. Yeah, I don't understand the Python stuff necessarily.
Mm-hmm.
I'm missing there. And all this does is just goes through and does K times whatever.
I think one thing we're missing is that there is this range of 19, like from 1 through 18, right? Not equals, but
Yeah.
because of the.
And that's what that's what we're iterating through?
Yeah, we're iterating twice, right? There's like 2 iterations happening.
Yeah.
We're gonna build 5 different sets.
Okay. And it's not in K, it's in range then.
Mm-hmm. So I guess can you I'm sure you can, right? Do like 4 I and K, then you do one more 4 here.
Oh, yeah. Yeah, you can do that.
You can do that, of course. Yeah.
Yep.
Python is not
You forgot the
reinventing the wheel.
there's this
Interesting. It goes inside the
curly braces. Yeah, it's yep. So yeah, for every one of these, it will go through 1, and it will do whatever 0 through 18 we're on times 1 mod 19 equals. And this should print out.
Interesting. The curly braces.
So yeah, it's
Iterator K prime.
it will replace the curly brace. I think it does, unless I have the wrong syntax. It will replace iterator. And we have to import range. Oh, it doesn't like that. Mismatch type. Just do this then. Can I multiply integer by usize? Oh, that's because we don't want to multiply by K. Multiply by I. Ranged mood to its Oh, okay. That's because it. I'm just gonna call this J for right now, because I don't have a better word for it. It basically didn't
Like
like.
a system command or something.
Yeah, I think range is. It's trying to detect range as something different.
We reserved for
Okay, and so this is some. Yep, and this is a Rustism here again. And it's basically because we have two nested loops here.
that. Mm-hmm.
And so the first time through, J gets used up. And so on the first time through with 1 in K, J gets used up. And so this probably need to do. Let me see. Let me think about this.
Gets used up, so like it starts at 19, like it's saying like, oh, I'm over this range. Is this what you're saying? The range is already at the end, so that you have to make it come back or something.
It has to do with the way that Rust handles things. So if you're using J, and then like the first iteration through K, it will it uses up J, and so on the second iteration through K, right, on when it goes through when I is 3, J has already been used up, and so Rust doesn't like that. And so there's a way, and I don't remember off the top of my head.
Inside, it won't, right? If you do this, it won't work.
Say that again.
If like I moved the J inside the loop.
Actually, it might work. Actually, it stopped complaining. We'll see what happens when we run it. Yeah, that worked.
It did. Oh, okay.
Yeah.
Cool. It kind of restarts it.
Yeah, because we're making a new J every time we iterate through K. Well done, sir. So here's. So what was you said what was the pattern that you saw?
So the pattern, and they give it away, like Sherlock Holmes here, but the hint, if you go back to the GitHub, there's a hint and they say sort.
Yeah. I imagine it's because these. I mean, we have 1 here, we have 2, and this is 3.
That's exactly that. Yeah.
Okay. Yeah,
so
yeah.
All these iterations are going to include every number in the finite field.
Okay, I get what you're saying.
And so when you sort them and put them side by side, they're all going to look the same.
Because it doesn't matter what the what would you call that number then?
The K?
Yeah, whatever the K is. Oh, like I guess the multiplier, or
what's the name of?
Oh, it doesn't matter. It doesn't matter what you're multiplying your set by. You always get an answer in the set. Or it doesn't matter what you multiply an element of a set by, you will get another element in the set.
As long as it's
prime.
Yeah, as long as it's like a closed multiplication or something like that.
Yeah,
not even, yeah.
Yeah, I'm not sure how the multiplication factors into that.
Because there is a modulo there, so it's
no, that is the property. That's okay. I think I know what you're saying.
Yeah, one of those 5, right?
Yeah, it's because these are all in the set. It is it's closed because A times B are in the set. right? So 18 times whatever in the set is also in the set because we're using modulo.
Mm-hmm.
Okay.
Exactly.
Yeah, yeah. Interesting.
Yes, good stuff.
All right. Next is going to be division. This is super interesting. Finite field division.
The division starts getting,
Yeah.
yeah.
Do you
Let's
think
figure
we
out.
have time for a division?
Maybe we just glance through, like we rush through it real quick,
Okay.
and then
Yeah.
go back.
So it's talking about an inverse, which I mean that's pretty obvious, right? Like, whatever I can't remember. It's like what quotient and divisor or something like that. Is that the name
The
for that?
product.
Products for multiplication, I thought.
Hmm. True, true. Yeah. Divisor, dividend, and quotient. Yeah.
Yeah. Okay. I knew it was on something there. So we can use this as a definition of division to help us note that, like in normal math, you cannot divide by 0. Okay. So we have a field of order 19, right? Because this is the order of the field,
Mm-hmm.
of the finite field. Oh. So 2 divided by 7 with finite math is 3. Huh. Yeah, it does look like fractions. Finite fields are closed under division.
You go back up a little bit, just to those two.
These?
Let's figure out why these are what they're saying they are. Is that what he's saying is that because 3 times 7 equals 2, and 2 divided by 7 equals 3. And
So
that's because you need the result to actually build the left side of the equation.
yeah. So let's do. So we know that it's order of 19. So we basically have to reverse the math here. So if the answer is we're starting with the answer of 2, I would multiply that by 19. Well,
We just know that it is for now, yeah.
yeah. But 21 mod 19 means how many times does 19 go into 21 with 2 where 2 is remaining? So it's 1 with the remainder of 2.
Yeah, he's just inverting the equation, right?
Yeah, but I'm not sure.
3 divided by 7 equals 2, or 3 times 7 equals 2. That means that 2 divided by 7 equals 3, which is implying it.
Yeah, but how do you know? Because you can't. Because also, 3 times something. Well, I'm gonna have to read. I have no idea. I have no idea how to reason about this one. Yeah. The question you might be asking yourself is.
Yeah, believe me when I say it. He's saying like 3 times 7 equals 2. 2 divided by 7 equals 3. Believe me that. Now he's going to explain.
I mean, I do believe that just because of the inverse, like the inverse thing.
Exactly, yeah.
Um,
He's gonna.
we'll have to use the result from exercise 7.
Mm,
Oh, so do you just find, in case you didn't get it, the answer is always, is that n p minus 1 is always 1 for every p that is prime and every n that is greater than 0.
yeah, if you go back to exercise 7, I'll just spoil you the answer. But if you build these four sets, they're all gonna be ones. It's all one.
Oh, really?
Yeah, and that's he's gonna explain. It's like the theorem, the little theorem of that. I don't know.
And is that,
But
so
more
1, because it's 1 to the power of
prime minus one.
6, right?
All right, yeah, let's calculate. That's good. So 1 to the power of 6. Yeah, we know what that is.
It, um, 1, programmer. Nope. 1 to the power of 6, 1. And then 2 to the power of 6, though, 64. But modulo
7.
7.
Modulo 7. Yeah, that's one. Right. That's so cool. Okay, let's keep going.
Okay. And then 3, 6, mod 7. Interesting. So and they're all ones, even if we did 11.
Yeah. Even if it did 11, even if it did whichever prime.
Huh.
And I think that's how he solved the division.
The answer is, yeah. Okay. So whatever the number is to 1 less than the prime is always 1 for every prime. And as long as the number itself is not greater than, or as long as the number itself is greater than 0. Number theory called Fermat's little theorem. Essentially, the theorem says, yeah, okay. P is prime. Since we are operating prime fields, this is always true. Yep, okay. Many proofs of this theorem, but for us, the simplest is that we saw in extra 5, namely that these sets are equal. The resulting numbers might not be in the right order, but the same numbers are in both sets. We can then multiply every element in both sets to get this equality. Oh man, this is deep. Yeah, I'm gonna
It goes super fast. I wasn't like totally getting everything at all. Totally.
well
Almost.
the prime minus 2 is I mean that makes sense. Like it's because it's up until like a finite field, a finite a finite field includes a number, all the numbers up to the order of the field minus 1. So that's all this is saying. This is saying the order of the field minus 1.
You're multiplying every number in the field basically
Yeah.
in this equation. Yeah.
And the left side is the same as
E minus 1 factorial. Yeah.
What is factorial again? Oh, this. Oh, where it's you multiply it out until you get down to 1. Okay. On the right side, we can put together all the n's and get so p minus 1 factorial times n, which this is just mod 1. That's I'm trying to read this and comprehend it. I'm sorry?
N is whatever number.
Yeah, any number in a field.
Mm.
A field element.
Field element. Yeah.
1 equals a field element raised to the order minus 1 mod the order. And is this because, so is this true because this is the inverse here? Or what is, oh, that's because this is 1. This right here, that highlighted section is 1, right? That's what we learned up in exercise 5. Is a field element to the exponential of 1 less than the order, modded by the order, is always 1. So 1 times.
You can really add that to anything.
Yeah.
Because it's times 1. You can just add as many as you need.
Well, it allows us to. I think it allows us to remove. That's how we that's how we simplify this down. Because this is just 1. It allows us to simplify the whole thing down to this.
Yeah.
And then the p minus 1 factorial cancels out. I don't get it exactly, but I sort of get it. And I think it all hinges on that whole exercise 5, like he was saying.
Yeah.
Because division is the inverse of multiplication, we know that a divided by b is equal to a field multiplied by 1 over b is the same as negative 1. Man, yeah, I'm gonna have to. I think I'm gonna have to pause, and we're gonna have to come back to this. I'm tired.
Me too.
I'm tired, and this is getting over my head here. So,
It's heavy.
yeah.
I guess one more week for chapter 1.
Yeah, that's fine. Hey,
More week.
low time preference, man. We'll crank this out. I might come back to this later this week. And I'm traveling this weekend, so I'll definitely have some time. Cool. Well, let me.
Digging my Bitcoin orange background.
Yeah, you'll have to. I'm gonna go ahead and stop the stream here. So in case anybody's out there paying attention to us, thank you for tuning in the stream. I'm Gary Spleblira, and we are here programming Bitcoin. Have a great night.